8.10 practice problems. The acid ionization equilibrium for the weak acid hydrofluoric acid is represented by the equation above. To prepare a buffer with a pH of 3.5, a student needs to mix 250 ml of 0.1 molar hydrofluoric acid and 250 ml of 0.1 molar potassium fluoride. If a student mistakenly mixes 250 ml of 0.05 molar hydrofluoric acid and 250 ml of 0.05 molar potassium fluoride, which of the following is the result of the error? So, the overall ratio between the salt and acid remained the same since we kept the number of moles relative to each other the same. So the pH will be the same. The capacity, though, that the overall solution has to act as a buffer is going to be compromised just because we have less of both hydrofluoric acid and potassium fluoride, the salt. So we would go ahead and see which of these answer choices match that assumption. A says the buffer will have a lower capacity because of the smaller number of moles of hydrofluoric acid and fluorine available to react if an acid or base is added. This is correct, but we'll see if there's anything that's better. The buffer will have a lower capacity because of the smaller amount of hydrofluoric acid and fluorine will lower the pH of the buffer, and the buffers with lower pH have a lower buffer capacity. This is not true. The pH of the overall solution is going to be the same, and also the buffer's pH is not indicative necessarily of the buffer's capacity. Instead, that is going to directly relate instead to the amount of each component that we have. C says the buffer will have a higher capacity because of the larger proportion of hydrofluoric acid and fluorine will ionize it at lower concentrations, resulting in the neutralization of any added acid or base. This is not going to be true. We are going to maintain our pKa at 25 degrees Celsius. Our temperature is going to affect the overall dissolution rates rather than the concentration, and only the concentration was changed, not temperature. D says the buffer will have the same capacity because a large volume of buffer solutions dilutes any added acid or base. No, so we are left with option choice A as our best answer choice. The equation above represents the acid ionization equilibrium for hydrofluoric acid. To prepare a buffer with a pH of approximately 3.5, 4.20 grams of sodium fluoride should be added to 500 milliliters of 0.1 molar hydrofluoric acid. The buffer is accidentally prepared using 90% pure sodium fluoride instead of 99% pure sodium fluoride. Assume the impurities in the sodium fluoride samples are inert. Which of the following best explains how the error can affect the pH and capacity of the buffer? So since I have some inert contaminant in my sodium fluoride, that means that I do not have nearly as much fluorine ions floating around within my solution, and therefore my pH is going to be affected and my buffer capacity is going to be lowered because I will have a overall lower amount of the conjugate base. So I am going to check to see which of these answer choices reflects that. A and B can be eliminated because they both say that the pH is going to be higher. Since we have a higher proportion of the acid, we should have a slightly lower pH rather than a slightly higher pH. And then between C and D, we are looking for that it has a lower capacity since we have less of the conjugate base, and that would be option choice C. The equilibrium for the acid ionization of acetic acid is represented by the equation above. A student wants to prepare a buffer with a pH of 4.76 by combining 25 mL of 0.3 molar acetic acid with 75 mils of 0.1 molar sodium acetate. While preparing the buffer, the student incorrectly measures the volume of sodium acetate so that the actual volume is closer to 76 rather than 75. Based off of this error, which of the following is true about the buffer prepared by the student? So we accidentally have more of the conjugate base than we initially expected to have, and so our pH is going to be changed, and also the just barely though, and then the amount that the buffer could accept any extra acid will also be changed. So we'll look for answer choices that reflect that. Answer choice A and B both state that the buffer of the pH will be slightly lower. This is what we would expect if we had added accidentally a little bit too much acid, not too much of the conjugate base. So we can go ahead and eliminate A and B. And between C and D, we're going to go ahead and check that out. So C says the buffer solution will have a slightly higher capacity for the addition of bases with the than the addition of acids, because the total volume of the buffer is 101 instead of 100, and the acetic acid is diluted. This is not going to be true. We accidentally added more base, so we have a larger capacity for our acid, not our base addition for the buffer. Option D says the buffer solution will have a slightly higher capacity for the addition of acids than for the addition of bases, because the amount of acetate added was higher than the amount of acetic acid added, and that is going to be our best option.